Hey there, Isla, Riley, and Violet. This is exercise 5B, and we're going to be looking into smoothing. So it's highly recommended that you watch this video in preparation for your investigation sack. It's going to be looking into smoothing. There will be a smoothing question on your investigation. There is also a process that you'll need to look into using your TI Inspire calculator. I've got the emulator up on here, so I'm going to showcase how to do a little shortcut. So what are we looking into for smoothing? So you would have looked into exercise 5A and the different type of characteristics around time series. We're going to do a process that's called smoothing, and smoothing is one of those topics that gets a bit confusing as to the purpose behind why it is. So I'll try my best to explain why we do smooth. It's going to be one of those topics where you look at it, you do it for an investigation, and then chances are you probably won't see it again. Because quite a few topics within maths, but this is one of them. So what are we going to do? Well, we hoping to achieve by the end of this, you want to be able to smooth a time series by a process called moving means. Now there's two different types. There's moving means, and there's also finding medians. Moving means is the one we're going to focus on, but it's good to know the difference between the two just in case you're going to be doing the exam. So either that's one for you. You've got to know the difference between moving means and find medians, and know when and how to use centering when smoothing. So here's an example of I think stock market prices when it came to I think it was Telstra when I looked into this, or there was some type of company that over time it shot out and it gradually increased their share prices as time went on. Now, if you were to look at the whole scope of this, you can see that there is this upwards trajectory going on. But if you were to really zone in on this on a day-to-day basis, there's a lot of activity that happens, and it's hard to make a prediction of where the price in general is going to go, whether it's going to crash or whether it's going to perform really well and keep going. So obviously as we zoom out, you can see that there is after around 1990, in between 1990 and 2000, you can see it shoots up and then kind of dips down again and then shoots up again. And so what smoothing does is it tries to eliminate all the noise that's happening to see what the general consensus of movement will be over time. This is a bit trickier to do on a kind of day-to-day basis, or it's trickier to look into on a day-to-day basis, but obviously when you zoom out you can see that type of behavior. Now there are instances when you can't exactly zoom out, you're only limited to the amount of information that you've got, and so smoothing tries to eradicate all that noise. It tries to see where the general trend is going, whether it's up or down. And now this can apply to any type of context. In this case, this is stock prices. You can apply this to general temperature or behaviors of certain things. It really depends on what type of context you're dealing with. Now, how do we actually smooth? If you know how to find the averages of numbers, the rest of it's actually pretty easy. Now, there's two different types of smoothing. There's the 3 moving mean and the 5 moving mean. And as the information within the title highly suggests, a 3 moving mean, you're required 3 different points of interest, and you're going to be divided by 3. That just finds the average. Now, what these points are and where you get them from is dependent on the amount or the actual information that you get. 5 moving mean, as it suggests, is adding 5 numbers and then dividing them by 5, and then this here will get you the average. So what's a good example of this? We'll jump straight into this one, and this one here it is a table that shows the temperatures recorded at a weather station at 9 o'clock in the morning for each day of the week that varies from Monday to all the way to Sunday. So this is a very basic example. This is a snapshot probably within a month or within a year, we've got these 5 varying temperatures. And you can see that there's this kind of like it slowly gradually goes up. There's this peak at 26.4 and then it drops down to 13.9. Very reminiscent of Victorian weather. So what we're going to do is we're going to calculate the 3 moving mean smooth temperature for Tuesday and the 5 moving mean smooth temperature for Thursday. So what does this process actually mean? You can get the 3 and 5 moving mean smooth temperature for every single day where possible, and we're just looking for the one specifically for Tuesday. So what this process includes is looking at Tuesday, and because we're doing a 3 moving smooth mean, we're taking the one before and the one after of Tuesday, adding those 3 figures up and then dividing by 3. So smooth Tuesday is just going to look like taking those figures, 18.1, 24.8, and 26.4, and dividing that by 3. Now you'll be able to do this process for every single number, excluding a few, which I'll get to in a second. So the smooth temperature for Tuesday is 23.1 degrees Celsius. So you can get a smooth for Tuesday, for Wednesday, for Thursday, Friday, and Saturday. What you can't get a 3 moving smooth mean is for Monday and Sunday. And reason being is based on the information that has been provided to us, we don't know what the previous Sunday's temperature is. That information hasn't been given to us, and we don't know what the next temperature after Sunday is within this table. So we don't know what that temperature is. And because of that, we don't have enough figures to be able to get that 3 moving mean smoothness. We can't get those figures. So when you are to calculate all of these figures, you're only going to get 5 of these temperatures after it's smooth. There's just not enough information for Monday and Sunday. Now this process happens again, as you can imagine, for the 5 moving mean. But again, when we're doing what is it asking for Thursdays, when we do Thursdays, smooth Thursdays, we have to get 5 of these figures. So like I did with the Tuesday, I've got Tuesdays and I move to the left one and to the right one to get the 3. With Thursday, because it's asking for 5, I have to get this one and this one, and this one. So those are the 5 figures starting at Thursday and branching off 2 to the left and 2 to the right. So what that means, we're going to get 24.8, 26.4, 13.9, 12.7, and 14.2, and divide all of that by 5. When calculated correctly, you should get 18.4 degrees Celsius. So this smoothing you can do to all the temperatures except for Monday and Tuesday, because there's not enough figures to the left for those ones. And Saturday and Sunday you can't do. Wednesday, Thursday, and Friday are the only ones you can do a 5 moving mean. So this process, while easy, can get pretty tedious, especially if you're putting heaps of figures in and you have to work out averages for quite a lot of those figures. Fortunately for us, there is a way that we can do this on the calculator, which I'll showcase now. So right now I've got my emulator up. I've gone into adding a list in spreadsheets when I've started a new document, and I've gone ahead and put in the same figures that we did with example 7. Now when you do a time series, it's obviously you can't put like the day in which the figure is. You just have to put day 1 to day 7 or whatever the time frame is. The temperature is the thing that does vary. So I've gone ahead, put all 7 figures in for each one. Now on the side here for C, I'm going to put the label of mean, and I'll put it at 3 as an indication of what the amount of figures that we need to get the mean. So mean 3 Now, this is going to have a column of this smooth data. Obviously, we can't get the first one, like we said before. We can't get day 1, we can't get Monday, but we can get day 2 all the way up to day 6. Now, what this looks like is going to be a formula. You're going to start off with putting the equal sign here. You're going to do open bracket, which is over here, and you're going to type in B1 plus B2 plus B3. Now, why those letters? B, because we're dealing with the temperature, so the column B. If temperature was here for whatever reason, you'd go A1 and A2 and A3. So B1 represents that one, B2 represents that one, and B3 represents that one. Close the bracket. Then we're going to go divide by 3, and we're going to execute that or press enter. And so what that does is it takes the first 3 and then finds the average of those ones. Now, it's going to be a bit tedious to constantly do that over and over and over again. So we're going to click on this, and we're going to click on the menu button. And there's a part that says actions, number 1. Is it actions or it is... No, it's data, sorry. Data and fill. Now, what will happen is it's going to ask what particular figures you want to fill. Now, for me, this is easy because I've got a trackpad, but for you, what you would use is the cursor pad that's in the middle of your calculator. So that, if I can show it to the screen correctly, that over there is what you will use, and you would drag this down all the way to the end, hopefully you don't overshoot it, until you get to 7. And even though 7 doesn't get filled out, so annoying, I was experimenting with this before, it's so hard to get it on 7, there we go. Once you get to 7, even though 7 is not going to be needed, it will get filled out and it will just be put a dash. You press the middle button or enter, and what that will do is it will automatically smooth everything based on the positioning. So this one here is B1, B2, B3. This is B2, B3, B4, B3, B4, B5, etc. So that right there is the smoothed part. Now, again, I can do the smoothing for mean 5, but what you would do is instead of B3, B4, B5, it would be B1, B2, B3, B4, B5 to get the smooth of B3, and then you just keep going in that trajectory. Next thing we're going to do is we are going to graph this one. We're going to showcase the difference between both of them. So what we'll do is we'll press Control I, and we'll add a new data and statistics. At the bottom, we'll change this to day. In time series, we always put the day or the time frame on the bottom. And on the left-hand side, we will put the temperature, like so. And we'll press menu, plot type, and the only one that's available is number 6, XY plot. XY line plot, sorry. So you can see that line that's happening there. This is cool. We're now going to map this against the smooth data. So we'll press menu again. We're going to go plot properties, and we're going to add a Y variable. And make sure you don't click X variable. You want to click a Y variable because we're going to add a second Y variable. And this here, we're going to put mean 3. And what the calculator will do is it will automatically make a new key for this. In this case, it will be orange squares, so you can see the smoothed out version of this data. Now, this is just a snapshot of getting the smoothness. What this is doing, it's eliminating that noise that's happening, or like the really high peaks and the low valleys, and it's trying to see what the overall trajectory is going to be. Now, the more information that you have, the better, and in fact you can do a 5-point smoothing, and you can see that it's going to show over time in which direction this is going to go into. So this is what we'll need to do for our investigation. It's good to have this awareness of knowing how to put it into the calculator and how to get the calculator to work it out, and then to also graph it to see visually what's going on. Alright guys, with that in mind, here's another example you see on the worksheet that you'll get provided with below, that shows you the manual working out of 3 moving mean and 5 moving mean. And there's the data that you can see there in your own time for the particular example. So questions 2 to 5, exercise 5B, page 274. This will be the last exercise that you need to do before the investigation. Best of luck with this one. And yeah, I'll see you in the investigation sack.